For these students, in this class, I am going to discuss about some important MCQs on force. So let's start. Question number 1. The magnitude of turning effect depends upon a force and pressure, perpendicular distance and force, perpendicular distance and energy, perpendicular force and point of application. See, just look at this diagram. This body is pivoted at a point, and there is a point of application of force. This one. A force is applied at this point at some distance from the pivot. So both the factors are important, that is force as well as perpendicular distance. So the correct option is B, that is perpendicular distance and the force. Next, a single force applied on a pivoted body alone is enough to cause rotation, is not enough to cause rotation, is able to produce the desired effect, none of the above. So just look at this diagram. See, only one single force is enough to cause rotation when a body is pivoted at a point. So correct answer is A, that is alone is enough to cause rotation. Question number 3. A couple is defined as two equivalent parallel forces acting along the same line from a couple. Two equivalent parallel forces not acting along the same line form a couple. Two unequal and parallel forces not acting along the same line form a couple. Two unequal and non-parallel forces not acting along the same line form a couple. So just look at this diagram. A body is pivoted at a point S and two forces are applied. The magnitude of these two forces are same, but the direction is different and they are not acting along the same line. So this is an example for a couple. So correct answer is B. Two equal and parallel forces not acting along the same line form a couple. So these are the two forces. As you can see in this diagram, these are the two forces, but the direction of these two forces is opposite. These two are the parallel forces, but the line is not same. So correct answer is B. Next, which of the following is true for the condition of equilibrium? The resultant of all the forces acting on the body should be zero. The resultant of all the pressures acting on the body should be zero. The resultant of all the forces acting on the body should be equal. The resultant of all the forces acting on the body should be unequal. So let's discuss this example. A book is kept on a table. You can see the action of two forces. One, the weight of the book acting downwards, and the other force is the force of reaction, that is normal reaction force. The magnitude of these two forces is same, but the direction is opposite. We can say that the net force acting in this case is zero. So the correct answer is option A. The resultant of all the forces acting on the body should be zero. Next, the center of gravity of a solid or a hollow cylinder is at geometric center, midpoint of the axis of the cylinder, 3/4 the axis of the cylinder, 1/4 of the axis of the cylinder. So this is a diagram of a cylinder. Let me draw an axis. So this is an axis of the cylinder. The center of gravity of this figure, that is a hollow or a solid cylinder. So answer is B, midpoint of the axis of the cylinder. So this point is the midpoint of the axis of the cylinder. So this is the center of gravity of this figure. Next, if the height of the wood is decreased, the center of gravity will increase, be lowered, will remain same, none of the above. So consider this example. The center of gravity of this wood lies at this point. Okay, let's consider this point as the center of gravity. If the height of this wood is decreased, means some of this much portion is cut off, then the center of gravity will not remain at the same point. It changes, but it will be lowered. Okay, as we know that center of gravity of a body changes if it is deformed. So here, when we cut off some portion, means when we decrease the height of this wood, the center of gravity will shift to the low position. So answer is B, that is B, lowered. Next, centripetal and centrifugal forces are equal and opposite in strength, equal and opposite in direction, opposite in direction, all of the above. So just look at this diagram. A body is in a uniform circular motion. We can see the action of two forces. One which is directed towards the center of the circular path, and the other one which is directed towards the circumference of the circular path. The one which is directed towards the center is called centripetal force. Its direction is towards the center of the circular path, and the direction of centrifugal force is away from the center, that is towards the circumference of the circular path. These two forces are opposite in direction. So answer is C. Next, which of the following quantities do not remain constant in a uniform circular motion? Speed, direction, velocity, both direction as well as velocity. So just look at this diagram. The body is moving in a particular direction. Its direction as well as the speed, that is a velocity, also changes. See, as there is a change in direction, velocity also changes, but speed remains constant. So answer is direction and velocity. So both direction and velocity changes. The centripetal force is a real force, the force of reaction of centrifugal force, a fictitious force directed away from the center. Look at this diagram again. See, there are two forces in action, but centripetal force, the force which is directed towards the center of the circular path, is a real force. So answer is A. Centripetal force is a real force, whereas centrifugal force is called as fictitious force. The center of gravity of a hollow cone of height h from its base is h by 4, h by 1, h by 2, and h by 3. So this is a cone, and h is the height of the cone. The center of gravity of the cone lies at h by 3. That is, when we make three parts of the height, it lies at 1 by 3rd, that is height divided by 3 times. So answer is D, h by 3. Next one, the effect of the two forces will be the rod rotates randomly, the rod will rotate in clockwise direction, the rod remains stationary, and the rod rotates in anti-clockwise direction. See the action or the moment of the force at point B. See, this body or this meter scale or this metal strip, whatever you can call, is pivoted at the point O. And the action of the force, that is a moment of force at point B, is in this direction, that is anti-clockwise. Now just look at the action of the force at point A, that is also anti-clockwise. So this rod rotates in anti-clockwise direction. So the correct answer is D. The rod rotates in anti-clockwise direction. Next, The SI unit of moment of couple is Newton per meter, Newton meter, joule per centimeter, and meter per Newton. So correct answer is Newton meter or Nm. Okay, let's go to the next question. The moment of force about a given axis depends only on the magnitude of force, only on the perpendicular distance of force from the axis, neither on the force nor on the perpendicular distance of force from the axis, both on the force and its perpendicular distance from the axis. So I think we have discussed this question earlier as well. See, the moment of force about an axis depends on two factors. That is the force as well as the perpendicular distance. So correct answer is D. That is both on the force and its perpendicular distance from the axis. So next question. The moment of force of 5 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of the force. Let me draw a diagram to explain this problem. Take this as a pivot point. This is a perpendicular distance and the force is applied at this point. So magnitude of the force is given as 5 Newton and the turning effect, that is the torque, is given as 5 Newton meter. And the question is to find the perpendicular distance. We know the formula of torque, that is force into perpendicular distance. So here in this problem, moment of force is given as 5 Newton meter and force is 5 Newton and perpendicular distance we need to find. Just simplify this. So correct answer is 1 meter. Next and the last question. The diagram shows two forces. F1 is equal to 5 Newton. So magnitude of the force F1 is 5 Newton and F2 is 3 Newton acting at points A and B. Force F1 is acting at point A and force F2 is acting at point B, such that OA is 2 meter and OB is 4 meter. The moment of two forces about O that we need to calculate. Okay, so let us take this distance as D1 and this distance as D2. That is OA as D1 is equal to 2 meters and OB D2 is equal to 4 meters. So let's find clockwise and anti-clockwise moments separately. So the force F2 causes clockwise moment and force F1 causes anti-clockwise moment. So let's find clockwise moment first. That is F1, F2 and D2. The magnitude of the force F2 is 3 Newton and the distance D2 is 4 meter. That is 12 Newton meter. So clockwise movement is 12 Newton meter. So let's find anti-clockwise moment. That is F1 into D1. F1 is 5 Newton and D1 is 2 meters. That is 10 Newton meter. So as you can see, Anti-clockwise movement is 10 Newton meter and clockwise movement is 12 Newton meter. So the difference of these two is 2 Newton meter. But this body rotates in clockwise direction as the moment is 2 Newton meter more in the clockwise direction. So the correct answer is 2 Newton meter clockwise. So that's it for today's class. See you in the next video. Thank you.